Hello everyone, today in this video we'll be discussing the module 2 of 18DIPMAT41. So in the module 2 we have the main two topics, which is finite differences and numerical integration. So the topics which you could expect the questions from are as follows: topic 1, topic 2, topic 3, 4 and 5, 6 and 7. Okay, so in these means I'll be discussing each topic and I'll be discussing one example, like what are the steps you need to follow and how you can solve the question from this. Okay, all the 7 topics are very important. Pay attention to it and solve as many questions as you can from the other PDF which I will show you just now. And this PDF and the other PDFs all can be found in the link which is given in the description box. Before starting, if you like this video and you want more videos like this, show your support to me by liking this video. Your support helps me make more videos like this. And let's get started with the first topic, which is finite differences, forward and backward difference and interpolation. So what type of question you could expect? Let's have a look at the question paper. So this is the model question paper. Let's go to module 2 and see what are the type of the question that could be asked. Okay, so this is the module 2. Here what they have asked is the to correct three decimal places lying in the interval using a Regula-Falsi method. This is the one of the topic, Regula-Falsi. Interpolation, the first topic. Weddell's rule, the seventh topic. And Newton-Raphson method, the third or the second topic. The first topic, interpolation, Simpsons 1/3 rule, as well as 3/8 rule. That is the fifth and sixth topic. Okay, so these are the questions which are asked in the model question paper. And in the model question paper 2 also, if you find out, if you see, if there will be the same type of questions. So let's have a look at how you are going to solve the different type of questions that are asked. Okay, so let's get started with the first one, which is finite differences, forward and backward difference, interpolation and its definitions. Okay, so let's directly move on to the questions and I'll be explaining you how you are supposed to solve the problem. Okay, so if the problem is given to you in this way, so mostly the problem will be asked in this way itself. The format is same, so that's why only I recommend you to solve as many questions as you can from this PDF. The same types of questions are present what are asked in the exam. Okay, so you just have to remember few steps for this. F is given to you, f of 1 by 1.4, so x value is what, 1.4. Okay, and this table is given to us. So the first step is we have to find out if 1.4 lies in the first half or the second half of the table. What we are supposed to find out? We are supposed to find out 1.4 lies in the first half or the second half of the table. 1.4 lies in the first half of the table, it lies in this part, so therefore we'll be going with NFIF. NFIF is nothing but Newton's forward interpolation formula. If it is lying in the first half, we'll be moving with NFIF. You have to remember this formula and I'll be telling you how to remember this formula as well. So let's get started. First step, what you have to do is you have to write the x values here and y values here. The first x value, second, third, fourth and fifth, and the first, second, third, fourth and fifth value of y. After you have written this one, you are supposed to find out the difference in y. The first two difference you'll be writing here. It is 16. 26, 58, the difference is 32. 58, 112, 54. 112, 194, 82. So after you have written this one, next you are supposed to calculate 16 and 32 difference, 32 and 54 difference, 54 and 82 difference. Then 16, 22, 22, 88, then 6, 6. Whenever you reach 0, you have to stop it. Okay, then you have to write this formula. In this formula, it's very simple. What you have to do is whatever the y values you have got here, the y naught value, y naught 2, y naught 3, y naught 4, all these four values will be using here. Fine, all these four values what we will be doing, we will be using here. So y naught, and here it is y naught square, y naught cube and y naught power 4. All these values are present here, and what we'll be doing is we'll be calculating r as well. R into r minus 1, r into r minus 1 into r minus 2 and minus 3. The first term 1 factorial, second factorial, third factorial, fourth factorial and so on. So this is how we'll be solving the question. If you write this formula 2 to 3 times, it will be in your mind. Okay, r value is nothing but x minus x naught by h. What is x? What is x naught? X is nothing but what is given in the question. What is given in the question? Make a note of whatever I'm telling. Okay, if you just simply listen, and after you close the video, everything will go off from your mind. Okay, so make sure you note down all the things which I'm telling. It will save your time. Here it is 1 by 4, so that is the x value you have to take. What is the x naught value? X naught value is the first value which is given in the question. Okay, so you'll subtract both of them, divide by h. H is the difference. Okay, h is given here as 1. because the difference between the each x value is 1, so that's why we'll take h as 1, and after that we'll get an answer here. That is the value of r. Wherever you find r, substitute those values in the r. Why not delta, why not square, why not cube, why not power 4, all those values you substitute here and calculate in the calculator, you'll get an answer. That's your final answer. This is the NFIF formula. For NBIF, what we'll be using is you'll be doing it in the reverse. When we will be using NBIF is only when the data which is given to us is in the last half. Okay. For example, construct the interpolating polynomial for the given data. Also find y at x is equal to 5. Now you tell me, where does x is equal to 5 lie? It lies above, beyond this one, right? So after 3 it comes. So at that point we have to find out the NBIF. Okay, it can be found by using NFIF also, but NBIF is the one which will be preferring. Okay, so in NBIF we'll do the reverse one, 0 1 1 2, and 2 3 is present here, and the y values are given here. Okay, same, the difference you'll write, the difference you will write, and the difference you will write. After all you have written the differences, just you will consider the bottom values. Instead of NFI, if you consider the top values, you will consider the bottom values, and the formula is also here. The simple formula, instead of minus it is just plus here. That's all the other things are completely same. Substitute those values, and I hope you get know how to calculate those answers in the calculator after substituting the values here. So that's what you will get in final. Whatever your answer you get, that's the final answer. Okay, put x is equal to 5 and you'll get an answer. That is the final answer. So that is the basic thing which is present in this question, and few more questions are there. Practice it for your more depth of knowledge. Okay, I'm just discussing what is the brief overview of each topic. Okay, so let's move on to the next one, which is second topic, and second topic is regarding the solution of polynomial and transcendental equations. This is just a very simple topic. All you have to remember is a few key concepts. So I'll be telling you what are the key concepts. Basically the difference between two things you have to mention here. Okay, so basically what we'll be doing here is we'll be seeing the definitions of each of these. So all you have to do is remember this one: algebraic equation and transcendental equation. What is algebraic equation? Like x square 6x power 6, like that, like those things. Okay, I hope so you can get to know what I mean. And transcendental equation, how it is, like e power x log x tan x log power 10x. Those things, when it comes, it is transcendental equations. Okay, so that's what the second topic is, and moving on to the third topic, which is Newton-Raphson method. Okay, so in Newton-Raphson method, let's see how the question could be asked. This is the question, and what you are supposed to do is you have to calculate it to 4 decimal places the real root of the equation. So this equation is given to you. First, what you have to do, find f of x. F of x is the same equation. Then write f dash of x, differentiate it, and you will get it here. Okay, so f dash of x and f of x is present here. When x is 0, x is 1, x is 2, x is 3, like that, keep on doing until you find a difference. What do I mean by difference? Difference means it is less than 0 here, it is greater than 0. That means root lies between 2 and 3. Fine. So when x is equal to 2, it is less than 0. If it is 2.1, it is greater than 0. So I need not check till 3, I just need to check from 2 to 2.1. I hope you got to know what I mean. Okay, so what you'll be doing is you'll be performing some trails here. N is equal to 0, n is equal to 1, n is equal to 2. Take x naught value as 2 here. Apply this formula, f of x and f dash of x and x of n plus 1. The next x value what you'll be taking here is you'll be finding out in this way. Substitute x of n here. X of n is equal to 2 in this case. F of xn what you found here, f dash of xn what you found here. Substitute those and calculate the answer. Take this answer here, again do the same thing, again get the answer, and again do the same thing here. Like that, do 2 or 3 times until you get a similar answer. For example, like 2.09. see, 2.09 here is there, and here also you got 2.09. in fact 2.094 is same, right? So that answer you will be taking finally, and you'll be approximating the required root is 2.00946. Like that, the Newton-Raphson method works, and the different variations are present here. Again, go through it. The basic formula is what I told you. Okay, that's how you need to solve. Coming to Regula-Falsi methods, it's the same thing. Here are different formulas there. That's all what you have to use. The equation will be given to you. F of x is given. When x is 0, x is 1, x is 2. Calculate when until a difference comes here. Whenever a difference comes here, that means the root lies between these two. Increase the values by 0.1. Okay, so if it is lying between 1 and 2, at that time you will be reducing it, like x is equal to 1.9, you will see it is greater than 0, 1.8 it is less than 0. Whenever it crosses less than 0, that means it is between 1.8 and 1.9, because this is greater than 0, this is less than 0, that means the root lies here. How did we take from the back in this case, and in the previous one we took from the front, right? So why it is happening is minus 11 is very far from 0, 2 is 4 is very close to 0, so that means the root lies more closer to 2 than 1, so we have to reduce 2 and see. That's what we did here, and we found out the range here. And you just need to apply the formulas. If you go through it once, you'll get to know what I mean. 1.8, 1.9, f of a, f of b, that is already defined here. What is f of a and f of b? You have to substitute a and b in the place of x here and find out the answer here. Calculate c by using this formula and calculate f of c. Whatever the answer you get c, apply that in the f function, and one answer you'll get. Then the updated values of c, a and b, that will be using here. And in fact, what you'll be using is the c value what you got here, that you will be using in the next one here. What c value you get here, that is the next thing you will be using here. B will be remaining constant. So that's how the thing you need to observe carefully here. What are the patterns you need to observe carefully, and for each question you need to remember that pattern. So whatever the question comes, the steps will remain obviously same, you can easily solve. How do you remember that? Practice, 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 that's all. Practice, practice, practice. If you're not taking the pen and paper, go and take a pen and paper and come here and practice it just after this video. Fine. So that's how you solve using regular false method. See, a lot of questions are there. You can easily score marks in this subject. It's not at all a hard thing. Just practice and time is the thing what will cost you. Fine. You have to put effort and put time. That's all. Next is coming to second half. In numerical integration, we have how many topics? 3 topics are there. 1 by 3rd Simpson, 3 by 8 Simpson, and Weddell's rule. Okay, so 3 rules are there for 3 different scenarios, and here 3 different equations are given to us. We'll see how to apply these equations in different scenarios. When n is a multiple of 2, use this one. When n is a multiple of 3, use this one. When n is a multiple of 6, use this one. So let's take 6 only and understand all 3 of these, because 6 is a multiple of 2, multiple of 3, and multiple of 6 as well. So here the question is like the first question. This is the function given to us, and the interval is given to us into 6 equal parts using this this rule, and this rule. So the least and the highest value is taken as a is equal to 0 and b is equal to 6. N is 6 because we have to divide into 6 parts, and calculate the h value, b minus a by n, that will be equal to 1. After you have got that, what are the different points of division? How you will calculate? X naught plus h, x1 plus h, x2 plus h, x3 plus h, and so on. So you will get the points of division. And let's consider the following table. What is the point of division? You got write it here and write it as y is equal to 3x square. Y is equal to 3x square is the equation given to us. So calculate the y value from x. Calculate what? Y value from which? X. X are given in this way. You have to calculate the corresponding y values. After you have done that, apply the formula. The formula is very simple if you observe carefully. The equation is given here, that is equal to h by 3. H we already calculated. Y naught and y6 is nothing but from this table you can see and substitute, and here also you can do it, and the same goes for the next one and the next one as well. Only the formula differs, right? 2 to 3 times the formula, it will be staying in your mind. Okay, so basically that's all what is there. Practice more and more questions, and I don't think so there is any much more need to explain any more concepts. Just the practice is the thing, you have to do it more. Okay, so show your support to me by liking this video. That will help me make more videos for you like this, and thank you so much for watching. I'll see you in the next one.